or detailing the steel structures. Apart from IS 800/2007, they have to refer this amendment also. So what one need to do, and the engineer needs to do, he has to take a printout of this IS 800, and then he has to mark all the amendments in the hard copy. Otherwise, it will be very difficult. So what there is another alternate method available. So we have a national building code, which is NBC 2016. So this NBC contains our steel design code also. In that, there is a section 6. So section 6 contains the complete IS 800 is reproduced there. The beauty is it came with the amendments. That means the amendments which is issued in 2012 is already incorporated in this NBC. So this is the one beauty of that code. So what you can do, you can just download this NBC 2016, which is, I think it is called SP7 or something. So in that you have a session for steel, and you can refer that SP60 or NBC 2016 section 6. So that way you can eliminate referring IS 800 and amendment parallelly. Now coming to same thing which I mentioned now just now. That means if you refer NBC 2016 steel section part section 6, it is equal to what you are referring is IS 800 2000 plus your amendment, and there are some improvements also in it is mentioned in the NBC. So these two documents, instead of referring these two documents, you can also refer this NBC 2016 also. So that's the first thing I would like to mention. Then let's now go to the modeling part. So we will take up a small shed, a simple steel shed for today's demonstration. So all of us may be aware what are all the structural components and non-structural components in the shed or steel shed, you can say. So mainly the main frame columns. So what we are doing is, see this column. So this is a moment resisting frame. So rigid frame it is. And then you have secondary elements like purlin and other things which is running in this direction, purlins. And you have so these are all columns. And then you have rafters. This is rafters. And then you have purlins here. And then you have girts here. And the last element, you can say the bracing elements here. You can see the bracing is mandatory to resist the lateral loads in the steel structural system. So one direction you are providing a moment resisting system, and other direction you are not providing the moment resisting system, but instead to resist the lateral system you are providing the bracings. So that is a basic concept, and these elements are called girts, so to support your side cladding and whatever is required to support the roofing sheets, which are all called purlins. So this is structural components as such, you can say, and remaining all which are all non-structural components like your roof cladding and then your light, skylight, then your roof ventilator, those things, your canopy, those are all non-structural elements. So when it comes to a steel shed, what we are going to model or what you are going to analyze, mainly the file or your the STAAD model should contain the main frame. It should contain the main frame should be there as a rigid frame, and then you should have it contains the columns, rafter, and other things. And some people will model purlins, some will not model purlins. So anything is up to the designer. You can model the purlins, or you need not model the purlin. You can design it separately, because there's a secondary element. It will be mostly either it will be designed as a simply supported beam or as a continuous beam. Depends. And but in today's demonstration, what we'll do, we will take only the main elements like column, rafter, and then your so you can say stability beams. One beam will be running from one end to the center. So those beams we will take and we will make the STAAD model. So before we will see what is that final product we will see. once we complete the model, how its structure looks, it will be something like this. So what will be there? The columns, rafter, and your bracing. These roof bracings and your the side bracings, and these are all that stability members, you can say, as a simply supported beams. It will be running from one end to another. So this is what we are going to model in today's session. We'll start from the beginning. Just I would like to show how the end product will be. Okay, so let's go back to the slides. So we'll take a small shed, say you can say a store or something like that. So what there are 1, 2, 3, 4, 5, 6, 7. 7 bays of 6-meter dimensions are there. So each bay 6 meter, and like that there are 7 bays, and this is 15.25. So we'll take 15 meter. We'll take, and this column height is 7 meter. So simple model. We'll start modeling in StatPro. So like earlier I mentioned, when you go to STAD, there are two kinds of modeling techniques are available. So one is which is called your analytical modeler, and the other one is physical modeler. So it's again depends on the designer which one you want to use. Whether if you want to use analytical modeler, you can use that, or if we want to use physical modeler, you can use that also. So we'll start with analytical modeler. If time permits, we will see how to start how to model it in physical modeler. So okay, so let's go to the stat file now. Stat now. So I'll close this file. Let me start with the new model. So this is what I told, analytical as well as physical. So we will start with analytical. I give some name, create. So I'll just make some nodes, beams. This all of you maybe everyone will be knowing this basic concept. So I'll just make some nodes, beams. I'll go a little fast. (15 meter). So this is 7 and this is 15 meter. So I'll just make say around, normally the slope will be around 1 in 10 or something like that. I'll just make 1 meter in the upward direction for the slope. It will come almost 7.6 degree slope. It will come. So after that, you can give your properties. So what I'm doing, I'm just going for this Jindal sessions. That I am taking. Okay. So I'm just selecting some sections from the Jindal section properties, that profile here available here. So I'm selecting a UB shape from this for the rafter, and a UC shape for the columns. So this comes the sections which you are adopting earlier. You have to check whether it is passing or not, and then whether it is deflections which are under limit or not. Those things you have to check. So since I've done this earlier, I selected that sections which already is passing. But maybe when you are starting a new model, you have to start with your certain assumptions, And then once the modeling and design is completed, you have to check the sections you are selected is passing and it is safe in deflection and all those things. So let me just assign this to rafters, these two columns. Okay, so one frame is ready. Now I'll just make a translation repeat of this. So we have 7 bays of 6 meter spacing. So I'll make in global Z direction the repetitions. I can provide link steps, open base. So I can just click OK. So 1, 2, 3, 4, 5, 6, 7. So that frame is generated. So you know these properties already we are assigned. So no need to assign again. But we need to assign the properties for these stability elements. So what I can do, I can just select those elements. In the section database, I'm giving this time I'm giving say you can say data structure. Here there are some square hollow sections available. It's just for demonstration purpose. Okay, in your whenever you are doing your case, it will be something different. So I'm selecting 100 by 100 by 4 mm square hollow sections. And you can assign also. So now the next step is bracings. So as I mentioned earlier, bracing is mandatory for steel buildings. And before that, one more thing, what we'll do, these members, it will be moments will be released at these junctions because only in this direction, it's rigid frame. The other direction, it's not a rigid frame. So you have to release the moments there. So what you can do in the specifications, you can go to the specifications and then you can add beam specification. You can the moment release like start and end. So you have to release the moment in X, Y, Z direction. Then add and you can assign. And similarly, the end moment release. So you can see those elements are the moments has been released in the start node as well as in the end node. And next step is to give the bracings for this structure. So what we'll do, we'll give a bracings in the first bay and the last bay. So okay, before that we can do one more thing. I will just make some groups. So this will be it will be useful when you are going to provide dead load and live load, wind load, etc. So for that purpose, I will just make a group now. So I will this also require these elements. So I'll say roof left side. I'll make a floor group here. So just remember this step. This will be very useful when you are making dead load, live load, etc. Associate. So one group created. Similarly, in the right hand side also, we'll create one group. Create, mute. How it's getting mute? Okay, no, it's not mute. I think you can also unmute if possible from there itself. Try, yeah. So I'll give a name of roof right side, right? And then select this floor system. So similar way, you can make some groups for this node where you have to check the deflections at later stage. Once your analysis is completed, you may have to check the deflection at the later stage. So you can create those nodes as a group. So checking will be easy. Again, Control G, create deflection check. That is nodes only associate. Yeah. Right. Now we have to create bracings. So I'll select this bay and this also. I'll just create one center middle node here. So in the beam tools, or you can just right click and then insert node at midpoint. Shift K so that those nodes will be visible. So I'll just add the bracing beams here now. I'm just giving the bracing elements here. We can just copy these bracing elements and then put it in the other bay also. Right click, copy, or Control C, Control V also you can do. Can give some reference point. I'll select this point and then say OK. So you created your bracings at starting bay and the end bay. So you need to give the properties here again for that bracings members. So what we will do, you can select some say pipe sections or some tubular sections so that weight will be less. Also, it will have good stiffness. So what sections we will select in the section database? Go to section database again. Maybe this data structure, or you can have circular hollow sections with maybe 139.7. Yeah, let me select this section. Time being, I will assign all my bracing members with this section, hollow section. So you can select which is the missing properties, and they can just assign. So now we're done with the property assignment. Almost everything completed. Now next step is your support. Let's give a pin condition and yes, so supports also completed. Now next step is loading. So we'll create some primary load cases initially. So since we are planning to do the seismic analysis also, the first two load cases should be seismic in X direction and Y Z direction. Static, this equivalent static method because of that. So add, then EQ set, add, then dead load, add, live load, add. Okay, then wind load, we will see how to create wind load much faster in StatPro update. This version having some new features which is added. Using that, we'll generate wind load much faster. So we'll see that later. So I'm not giving any wind load case here. I provided only EQ set. Sorry, this is EQX set and dead load and live load. So in the dead load section, normally your sulfate will come, and of course sulfate you have to add. Then you have to add your sheeting load purlin. You are not modeling purlins here, so you have to give some some weight, purlin weight you have to consider, and you have to add it along with your sheet weight, and plus some collateral load, anything is there, all those things you have to add. So time being, I'm just considering say 0.5 kilonewton per square meter load. So you remember I created two groups earlier, two floor groups I created. So the advantage is when you are applying your dead load, live load cases, there is an option called group here. So these two groups which you are created earlier, like left side and right side, that will be reflecting here. So what I can do, I can give as a floor load here, minus 0.5 kilonewton per square meter in y direction. And first in the left hand side, as a one-way distribution, I need to apply. And you have to mention the program that it's an inclined flow. So once that is done, you have to just say add. So once that is added, you can see that loads are applied. Some issue with yeah, some when you are given some elements we broken, so that time the grouping got disturbed. So no problem, we'll create that group, define that group again. I'll just delete this, or I can reassign from here only. Highlight. I need to add these elements in the group. Associate. Yes. And right, highlight. Associate. Yeah. So this is your left side group, and this is your right side group. Yes. Okay. So let's we will just delete this node and apply it again. Sulfate anyway you can assign to the view. And dead load, add, then come to floor load, and then say minus 0.5. I'm applying group. I'm selecting group and left. Let's see whether it works or not. Inclined flow, add. Yeah. Now you can see that load, the entire group which we selected, the load is applied here. See, normally what we will do, if it's a conventional case, what we will do, if purlin is not model, we have to calculate the weight on purlin, and then we have to apply as a UDL here. So in this time stat does it automatically. So what it is doing based on the span. It's automatically getting muted in between. So what we are doing, I'll mention from starting. So what we are doing, we are applying as a floor load here, and what program does is it takes the span, means this is 6 meter span, and then you are applied 500 kg per square meter or 0.5 kilonewton per square meter load in as a floor load. So what program does, the half portion, you can see this half portion load and this half portion load, that the program calculates it and apply as a UDL automatically here. Normally this no floor load we know in X range, Y range, Z range we normally apply. But when it comes to steel buildings, there is this is one easiest method you can apply by creating the groups. So this will save our time much, very much compared to calculating all this span and everything. Instead, you can apply the load directly. So this is one advantage. So in the right side, this is in the left. Right side also you have to give the same kind of load. So floor load, say minus 0.5, the group, right, and one-way distribution and inclined flow. So just add. So right side also the loads are applied. You can shift see the value. You can just see how it is calculated. The shift V, if you press, the load value will be displayed here. Okay, right, yeah. And now we'll go to live load, add, then floor load. I'm applying a live load of minus 0.75. Group, one-way distribution, incline 4. So left side and then right side. Okay, so your dead load, live load is applied completely. The next step is wind load. So what we are covered, see, member material specification we have done, and properties. Properties as usual, the materials section, if you go, steel, the program already has some inbuilt properties for the steel that will match with our IS code values, which is mentioned. You can cross check this. It will be almost matching with those properties. So you need not change anything. If at all some like 275, 250, that grade design value you have to change, but not the Young's modulus or Poisson ratio. Those things mostly it's no need to change those things. The next member specification we have seen how to release the moment in the start and end of the beam elements for a stability beams, that longitudinal beams which we have provided. Yeah, that bracings we are not released the moment, that also we have to do. So we will go to that specification area and we can define these bracing as a truss elements, so that the program will understand that it will take only the axial forces there. So what we can do, we can select by property the bracing elements you select, and then in the beam you truss and say assign. So now the bracing elements provided as defined as a truss elements. So specifications done. Then we come to loading, and in the loading we have seen the one easy method to apply the dead load and live load in the inclined floor. We have seen that. Next comes the live load. Sorry, wind load. So wind load anyway, IS 875 part 3, we have to refer for application of wind load. So anyway, it's a detailed session required to cover that. If you go through that wind 875 part 3 code, then it is clearly mentioned the steps required to do that. So when it comes to the program or STAAD, in the latest version update, I think I don't remember which update 8 or 9, from that time onwards, they introduced this wind load generator. So currently you can generate the wind load as per 875 part 3 2015 code from the program itself. So once you click that, this window will come. So currently you have only rectangular clad buildings, and the height, the elevation, all those things will be picked up from the model automatically here. You need to just provide the wind velocity and the other parameters. So let me select Chennai from here. So the wind velocity 50 comes automatically. You can edit if you want customs. If you click custom, then you can edit it. And the risk factor coefficient, the drop menu is available. You can see based on your the specification, you can select it, and which structure, industrial or other structures, you can select, and terrain category you can select, and then see 875 again. These three values you have to give as a input in the STAAD. So one is wind directionality factor, area averaging factor, combination factor, Kc. So these three values you have to calculate manually, and you have to provide input. So I calculated those earlier. So I'm just providing those values 0.9, 0.8, 0.9. Right. Okay. So now once this page is completed, now we can go to next page, wind load data. In that again, your length, x, z height, it picks up from the program. And if you click here, no, this is the wind directions, x direction plus x, minus x, plus z, minus z. All those things will be there. And like I mentioned earlier, this requires some time to first time when you are doing it, maybe you may feel this difficult, but once you go through the 875 part 3 code, this will become simpler. And the pressure coefficient automatically based on this dimension, it will the program will calculate those values here, A, B, C, D, at which phases what coefficient should be there, and the openings. And you can select the percentage of openings. So if based on that value, your CPI value will be changing here. So once you select all these design parameters, simply click generate. So the program automatically create all the load combination. That means we normally we have 8 load combinations for this wind load case. Means when you are considering plus CPI plus and CPI minus, you will get 8 load combinations as per 875 part 3. So all those load cases, primary load cases will be generated by the program automatically. The wind intensity also you can see the wind intensity also calculated here correctly for based on the height 058, the intensity calculated, and the load cases, primary load cases also generated automatically here. Now one thing you need to take care is the program, it will not calculate the wind load on the roof as per this wind load generator. The roof, the load calculation on the roof, it will not perform. But since you are defined the height as 8 meter, the wind is applied in this area also. So what I normally used to do, you just remove wherever x direction comes, means in the x direction, global x directions, wind is there. You come to that particular design command, load command, and then just put mention your height till what height you want to apply the wind load. So you can see here that earlier it was 8, it was going till this level. Now it's applied only 7, applied only till 7 meter height. So this you need to repeat for all the X load cases. So I'll just make it for all the X load cases. Seven. In the other direction, the global set direction, you need not do like that because you want the load to be applied till that height, right? So 7. Just changing all the values to 7. Whenever wherever there is load is applied in X direction, I'm changing it into maximum height 7 meter. Yeah. So what we did, in all these 8 load cases, we removed the roof wind load from the the wind load from the roof we removed. That is what we did here. So we need to apply it separately. We'll just cross check all the X load cases are removed. Yes, it's removed. Yeah. So this is done. Now I'll just want to introduce another small cloud software which will be very useful for calculating the wind load. So that the cloud software name is SkySieve. So you can just go to skysieve.com website, and you can create a free account in that. So the wind load generator for the basic load, I mean this kind of simple structures, it is free. For the free account, you can calculate the wind load on the uh, simple kind of structures. So once you create the account, there is a section called wind or snow design here. So you come here uh, and you select the design code. The beauty is there are some 4 or 5 design codes available. So maybe once you are a fresher or student, or if you want you are not familiar with the American codes or BSEN codes, then initially to learn also this will be a very helpful tool. So we'll select 875 and then proceed. And initially you have to give the project address. I'm just selecting Chennai here. So the basic wind speed comes automatically, and you have to just give the wind direction, terrain category, then your structure type, importance factors, and then that's all. Yeah. Now then come to structure data, buildings. Yeah. This select the roof profile. So you can see the roof profile. This simple. This first one is free for all the free accounts also, but the other like monoslope and other things, it is for the paid versions only. It will be available. So we will select only this one, and you can say the building length 42 meter, width was 15 meter, and reference height say 8 meter, and 7.6 I think the angle was. And you need to just fill these values. Uh, no dominant openings. So these are all design parameters. So once you select all the design parameters, just click generate loads. Okay, so now the loads which you need to apply for each zone, it's generated automatically here, like CPI, CPI plus, CPI minus, all those things it calculated automatically. You can see a detailed load report also. You can generate a detailed load report also. So it may take a few seconds. I think I already downloaded that. So you can download as a PDF. So what will happen? It will give the project name. Even thing is, you can zoom it to the site, and then you can get exact location there. So when you are making a report or something, this will be more attractive way sometimes to the client. So the length, the parameters which you have mentioned will come here. And initially it will calculate the pressure, design wind pressure. It will calculate from the basic wind speed which you are calculated based on the location, 50. Then K1, K2, K3, K4 factors it will come, and afterwards we will see the KD, KC, Ka factors. So finally you will get the design wind pressure you will get. So you can just maybe it maybe I'm running through fast. You can once go to the software website. It's a cloud-based software only. You can go to that website and you can uh, try this. So you're getting a value of 1.388 kilonewton per square meter. So same value only we are also the STAD also calculated here. You can see the intensity 1.389 value. So same value you'll get it from the STAD also. Right. So this is the software, and now we need to apply the roof wind load. We applied the wall wind loads in the STAD automatically generated those wall loads, but in the roof you need to apply the load. Either you have to calculate manually or you have to calculate from a programs like this. So wall at 0 degree, wind angle at 0 degree, wind angle at 90 degree, and this is for the wall, and the roof pressure it is giving separately, like means 0 degree. This is the pressure. So what I'm doing, I'm just applying this load in the STAD. Yeah, I'll go to the first load case. So this will it may take some maybe 3-4 minutes. because you have to just carefully see that. So first at x direction 1.67. So what I will do again, floor load I can use. So wind load will be this minus direction means it is acting upwards away from the structure. So 1.67 group. It will be in the windward, leeward. Those direction you have to see. Initially, if you are not familiar with wind load application, this may be you may feel difficult. But as I told earlier, you have to just go through the IS 875 once. Then it will be simpler. So in in the windward side 1.67 upwards, left side. So add, and the other one is at my 1.11, the right side, leeward side 1.11. Add. So those two loads added here. Now this is at minus CPI, means wind load in x direction minus CPI value. Minus CPI value is 1.11 and minus 0.55. So I will just say add floor load again. Value is 1.11 and in the leeward direction it is 0.55. So x direction means your 0 degree, wind angle 0 degree, x plus CPI minus CPI is done. Now you have to come to this 90 degree. 90 degree. Sorry, not 90 degree, minus x means wind acting in the other direction. So in that, what will happen? Your windward and leeward direction will just reverse. So earlier loads which you are applied, you have to just apply in the opposite direction. So add floor load group. So the first one you will apply in the right side 1.67. And the other one is 1.1. Then next minus CPI, add floor load group. First you will apply 1.11. And next you will apply left side 0.55. So next comes your set direction. That means your 90 degree case. So add floor loads 1.4, 1.45, and then right side 1.11. So then minus CPI. That means minus 0.89 and minus 0.55. So add floor load group minus 0.89, sorry, plus 0.89. Yeah, 2 times came, we'll delete it. 0.55. So then comes in the minus z direction. So add floor load 1.45. And the last one. .89 and 0.55. Yes. So we applied the wind load cases also. Madhu, we told 1 hour or 1.5 hours? 1.5 hours. No? Okay. Right. So now the wind load application is also completed. So all load as per your IS 875 part 3 is applied now here. Now we left out with the seismic load. So seismic load, what you have to do, you have to define the seismic load initially. So in the definition part, you have to go seismic definition and say add. In that you can select your design code, seismic design code, say 1893 2016 code. And you can just generate the same way which you done earlier. You can select the city or the place you are designing. Then select the type of buildings, steel buildings with ordinary moment resisting frame. And your type of soil, steel buildings. So generate those factors, your values will be generated automatically. Then just click add and it will go here. Now, since you are doing a seismic analysis, the program requires a seismic mass, or to calculate the lumped masses, the program requires the mass loading. So what you can do, this is again a new feature in STAT. What you can do, you can go to the reference load definitions. See, after the wind load generator, there is something something called mass model generator. So in one click, you can generate all these lumped masses mass matrix you can create in one click. So since our building roof live load, we need not required for generating the lumped mass, only dead load is required. Select that one, apply the factor, and just put generate. So in the reference load definitions, you'll get a mass model with all this self weight in X, Y, Z direction, and all your dead load will be automatically added in all the 3 directions. So this is also one new feature which is available in the STAT Pro latest updates. So now you are done with the definitions, load definitions you have done. Now next you have to give the primary load case for the seismic. So add and then seismic loads, then X direction you are applying. This is 1893 load. So seismic equivalent seismic method, you have to just put the factor as 1, add, then again EQ seismic load, then the factor is Z direction 1, add. So all your primary load cases are now completed now. Right now, the next step you have to make the load combinations. So there is something called automatic load combination here. This feature was earlier also available. So you can just go to this automatic load combinations and you can select the AS 800 code and 800 2007 table 4. So one click, all the load combinations will be created automatically here. So you can even edit this load combinations also in case you required. That anyway, we are not covering it now, but that option is available here in edit load. What is this combination which STAT is applying? How to find out that you can see it from here in this area. So ours is 800, 456 800 and 2007 table 4. So what load factors are applied? It is mentioned here. So either you can change it or you can add new combinations. So in case there is a temperature load, you can create your own combination here. So all those features are available, right? Okay, so we generated the load combinations also. Now next step is analysis. So we have done with the wind. wind load generator we have seen, and then mass model generator we have seen, then automatic load combination also we have seen. And this is the table for the load combination or load factors, which you'll get it from either IS 800, or you can refer your National Building Code. And even you can create some envelope, means you can create some strength envelope and serviceability envelope. So strength envelope is required for designing all your members, and serviceability envelope is required to check your deflection in your support reaction. If you want to take all those cases, will be from serviceability envelope, and from this is from the strength envelope. So what you can do, you can make some envelopes here. So come to this area, load envelopes, add. So you create one load envelopes for say strength. So I will select the load combination from all these factored load combination will be strength. So I think up to 180 or something it will be factored load combinations. Okay, what we done, we have not given the load combinations from 100 or something, so you have to just see that. All these are factored load combinations. So we'll just, yeah, till here it is factored load combination, then it is unfactored. So this is strength load combinations. Number is from 93 up to 93. Then select, make one more envelope for serviceability from 93 onwards, 94 onwards till the end. So this will be your service. So two envelopes you created here, one for strength and one for serviceability. The next step will be analysis. So coming to this analysis area, you have to give analysis command, perform analysis, add. So given perform analysis, then you can just see whether the program runs or not. You can just see by running the analysis. Yeah, so it's run completely. Then you can give the design parameters now. So in the design tab, you have to select steel, and then you have to select the design code, and then you have to give the design parameters. So the parameters, again, this like wind load, which I mentioned earlier, this also requires some time to familiar with these design parameters. So time being, I'll just mention some important design parameters only. So the beam design parameter is to perform design at ends and 1/12 section locations along the member length. So it's mentioned here. Once you click the element or parameters, what the parameters perform, it is mentioned here. So by seeing that, you can do all those things. And the another important parameters will be your the effective length factors which you need to input. If you are breaking the member at the center, like this column, you are breaking it with a node here. So you have to mention the effective length parameters for those beams. So similarly for the beam, this beam is spanning from here to here. So you have to give the effective span LZ parameters as 15.5, or the actual length you have to give. So I'm just giving that LZ parameters. And for the columns also, I'm giving 7. And LZ also, I'm just giving 7. So only this much parameters I'm giving. So assign to view LZ parameters for all the rafters. I'll select by property and then assign. And then the columns I'll give. So then you have to give your check code command, whether your design is safe or not. You can come to know. So now right now you're giving only minimum number of design parameters. Again, it's depend based on your structure, its complexity. It will depend. This is a simple model, so the design parameters required is very less. And if your model is complicated, this will also, you have to be very careful when you are giving the design parameters. You can just run and see what it is. Yeah, there is no errors coming. Only one warning is there. So you can just see the member is passing by double clicking it, whether it is passing or what ratio it is passing. You can see 0.72. Then you can go to your post processing mode. You can see the deflections here, and you can see the utilization ratio. What ratio? Since I mentioned earlier, I know I selected the members such a way that all the sections are passing. So whenever you are doing your analysis, definitely you have to do some trial and error so that you will be arriving the optimum design sections. So it takes some time, but for this demonstration, since we don't have time, I just took the almost the passing sections I took here. So you can see the utilization ratio. It will say UC ratio, at what ratio the structure is passing or failing. It is indicated here. And you can check the deflections also. You can see the displacement here, and you can annotate the values from here. Also, you can find the moment in Z direction. Like if you want to see the moment in moment values of any frame, you take that particular frame and you can study where your moment is maximum, where it is less, and load combination also you can change it from here. So all those things are there in the post processing mode, as you know already. Uh, then what else is there now? You can check the deflection, what deflections you are getting. So just click here, and then you can go to the displacement, and this is the displacement table. You can go to the summary and just right click here and go to result step setup. So here you take the serviceability envelope, means our envelope 2 you take, and then range. You remember you created a group initially for deflection check. So if you select that group, then you will come to know what is the deflection here, 36.017. Then again, there will be some caudal limitations for your checking deflection. For vertical deflection, span by 180, 150 for horizontal deflection. So all those parameters or design deflection parameters will be there. Those things you can check by using this table. Deflection check you can do. So once two things you need to check. One, your deflection should be passing. That is an important thing for any structural steel building. And second thing is all your members are passing. You can even select. You can go to select and check here whether any failed members are there. You can see that in the select. You can go and failed beams you can select. You can see if any failed beams are there, then it will be that members will be selected from here. So this is what in general we will do for modeling and analysis of a steel shed. Now I'll say one more thing. I'll just show something like there are a few more features, or you can say some advanced things in the steel design, which I would like to indicate. Uh, I think I'll take maybe another 10 or 15 minutes maximum. So maybe few slides, but I'll run very quickly all these things so that no, it will be maybe it will be useful for many of you. So where we reached, now we done we applied load combination actually in this case. But some places, when especially when it comes to steel design, these load combinations will not work sometimes. So that time you have to give repeat load. So we'll see where it is required. So the analysis part, you remember what we have done is we have done a uh, first order elastic analysis we have done. So you remember perform analysis, what STAT does is a first order in elastic analysis. But especially when these lateral loads are there and your structure is very light or something like that, then you need to do a second order analysis. So what will happen in the second order analysis? What we need to check is we also called as P delta analysis. Everything you might have heard this name P delta analysis. So what will happen? You have a vertical load and a horizontal load here. So in static or first order analysis, what it does, this load will be there V. Sorry, this is first order analysis. This H will be there. So you'll get a moment here. So that moment will be equal to this horizontal load into this height. This is the height. So H into small h, that will be your moment. But what will happen? Due to this horizontal load, the member actually deflects slightly here in reality. So then the load application point, means earlier in your model, you are saying that it is actually it is acting at the center point of this member. But in fact, in reality, it is not the case. Slightly the member is deflected here and the load is now applying it here. So this will create an extra moment in the base. So that is V into the small delta. So that is what extra one moment will be there. And due to that moment, again, some deflection will happen. So it will converge at certain point. So that is what we do in the second order analysis. But in the first order analysis, we will not do all those things. So it is called second order analysis or P delta analysis. So many times it will be an iterative analysis. You have to mention the program that say 50 iteration you do, and now you tell what is the actual deflections or moment coming based on that 50 iterations. So that is what P delta analysis or second order elastic analysis will say. So it's a non-linear analysis. So this is a linear analysis, linear elastic analysis, and this is a non-linear elastic analysis. Okay. So whenever you're doing a non-linear analysis, the load combinations will not work in StatPro. Instead of that, repeat load cases you should apply. So what is the difference between load combination and repeat load case? What is that in the program? So in simple case, if you say I have two load combination, one vertical load and I have two primary load cases, one vertical load and one horizontal load, lateral load. So when I'm making two load cases, case one and case two, and making a load combination, what program does is it will calculate the moment or support reactions or for this particular load case and this second load case, and just it will simply algebraically it will add. That is what in the load combination does. But in reality, these two loads are acting together. So when it is acting together, you need to consider these two loads simultaneously and you have to do the analysis. That is what the repeat load case does. So when you assign a repeat load case in the program will consider those loads simultaneously acting at the structure and it will do the analysis. So that is what we required for non-linear analysis. Hope I think I am clear. So how to do that repeat load case? You will see that in the loading, there is automatic load combinations. In that, when you are selecting the design code and your tables, everything is selected, what you need to do is, see here there is an option called create repeat load case. So just select this tab, create repeat load case, and then generate loads. And then once you add that, you will get the repeat load cases in the program. So this is how you have to generate repeat load case instead of load combination. So as I mentioned earlier, whenever you want to do a P delta analysis, you require to make repeat load cases instead of load combination. So this is one important thing which you need to remember. And we'll go to our slides again. So we mentioned P delta analysis. And one more time, you need to do the second order analysis. One is this P delta analysis. When somebody asks that when you need to do a second order elastic analysis. So first case is whenever you are designing a member or the stat gives a warning like this. So it suggests automatically like for certain elements, it says that the value of moment amplification factors Ky or Kz is greater than 1.4. This is a particular clause in 800 IS 800. So section 4.4.2 IS 800 2007, there is a clause to calculate Kz and Ky factor. So those factors, if it is more than 1.4, then the code recommends to you to do a second order analysis. And the second condition when is the buckling factor. When your buckling factor say more than 5 or something like that, so that time also you have to do a second order analysis. So in these two conditions, you have to do a second order analysis. I know that I am fast, I could not able to explain completely, but still you can just remember that there is whenever you are going through IS 800, there are two parts wherein the code specifies you have to do the second order analysis. So that time when you are doing second order analysis, you need to go with repeat load cases instead of load combinations. That is the one I would like to specify. And see, we'll just see what is buckling analysis. We'll just see. Buckling analysis actually, any structure before reaching its actual material strength, the failure happens. So that condition is called buckling analysis. So you can imagine some very slender member, and even if you apply very small loads, that what you can say, that member is subjected to easily subjected to failure. So that is called buckling failure. So many types of buckling failures are there: flexural buckling, torsional buckling, lateral torsional buckling. So many types of failure are there, but in the program we can check only flexural buckling. So there are two methods to check the buckling load. If you want to find out, when you are modeling, designing a structure, if you want to find out the buckling load of that structure, you can find out using these two methods. So I'll show where it is. I think I already done one example, so that it will not take much time for you. This I'll just make this buckling analysis command here. I'll just show you how it is. You are getting the buckling analysis. So you have to come to analysis tab, and then your analysis comments is there. Here, instead of this field delta analysis, you can just select this buckling analysis, and you have to give either there is an iterative method or eigen method is available. So both are there. In eigen method, you can also see the buckling mode shapes, but in iterative method, you will not see that. So that's the only difference. Then say add. I think I already given here. So this is what the eigen method buckling analysis. So just give that command and run your analysis. So it may take maybe a few seconds, because it will take some more time than the normal analysis. So by the time you'll just see, yeah. So design parameters, as I told, no, there are many design parameters like STP. There is one parameter is called STP. So when you are using your hot roll sections, it will be 1. That is a default value. And if you are designing some PEB or something, you have to select 2. And the ratio, this is the permissible ratio of actual to allowable stresses. So you can, some clients say, if some of your clients want to limit your UC ratio to 0.95, you have to get it from here. You have to change this factor, then track value, all these things. You have to go through the stat manual, and then you will understand. And this is a deflection parameter or deflection limit, in fact, from the IS 800 code. Let me check this is completed. Yeah, it's still running. And one more thing I just would like to mention is notional loads. So any structure, this also is there in the IS 800 design code. So what it says is, any structure, if you take, there will be some imperfection, practical imperfection will be there in the structure. So to take care of this imperfection, the code suggests you to apply 0.5% of the factored load. Go through this 10.3.6 later, and what it says is you have to apply a load of 0.5% of the factored loads plus vertical imposed loads applied in that level. So notional loads also you have to apply. So in that case, your load combination will increase considerably. So that application of notional loads also is there mentioned in the one program. You can generate those notional loads automatically. That command, I'll just show you that. Let's see this completed or not. Yeah, it's completed. So the program, the buckling analysis we have done, and you go to the post processing area, and from here you can see this layout and your buckling factor. You can see the buckling factor here. It's 67.93. What it means is, currently you are applied say 100 kilonewton load on the structure, and if you multiply that into 67 times, this structure will buckle. That is what the meaning is. So when this value is say you are getting say 3, 4, then you can understand that your structure is very light, or it's not. Your analysis should be very critical at that time. Then that time you have to go for second order analysis. That is the meaning. That is why we need to find the buckling factor. But if it is more than 5, then it's okay. Then more than say for 10 and above, then it's not so critical like the case is. So that is what buckling factor. And notional load, we have seen that load combinations, how to apply the notional load also, we can get it from here, automatic load combination. In that, you select the design code from here. And when you are making the repeat load, include notional load like that, there is an option here. So here you can just change the factor to 0.005 and you can generate the load. So that is a procedure for notional loads, right? Okay. Now another one more feature in StatPro I'll mention and I'll close. So what there is a section called Steel Auto Drafter here. So what it does is, once your analysis is done or design is done, there is a section here called Auto Drafter, Steel Auto Drafter. So like RCDC, or you can say not like RCDC, but in a certain way, if you want to give your design inputs to your drafting team or some designers like that, then you can go to that Steel Auto Drafter, and then you can come to the drawing sections, and you can generate the drawings from here itself. I'll just show you some. You can maybe further explore later. Like I'm making a plan at projections, and 3 nodes I'm selecting. 1, second node, 2, third node here. Okay, then create it. See, your drawing is created. So you can just save it in your CAD file or DWG file, DXF file, and then you can further edit it. This whatever grid dimension which you are mentioned in the STAD with the grid properly, everything will come. So almost the properties, member properties which you are defined. So to the scale it will be drawn here. So this is one feature available in STAD, and you can see you can generate plan, different type of plan sections, all those things you can generate from here. So this is one feature which is available in StatPro. So I think with that, maybe I'm finishing it. Maybe I would like to say one more thing. This session means whatever session you are attended, you will be getting a certificate from your Bentley directly, because we are associated with Bentley, and then I am a authorized qualified trainer for STAT. So Bentley will be directly giving you the certificate once you give us the your name, email ID, and your institution name or something. For students, this may be helpful for their interviews or something like that. So you can get the certificates like this. And some few things which I am mentioned, which like if you want to download the Indian if you want to download some say some what you can say Indian standard or something, how to download if you don't know, I just put some created some YouTube videos are there. So you can just go through this video YouTube links, and it's a small 2-minute 3 minutes videos, and you can see how the codes can be downloaded, like how notional nodes applied, then Steel Auto Drafter which I mentioned now, and one of the main feature like PEB modeling. So there is an easy way to model PEB structures in STAD. So you can just go through this link and then you will understand how it is done. It's a 2-3 minutes video only. So those features are mentioned here. And similarly in RCDC, when it comes to RCDC, see our structure is, we model only up to this now, only structural steel part. But we require a pedestal here below this and a footing here. So that also can be done with RCDC and STAD. So you have to just import the model to RCDC, and then you can get the pedestal design and the footing design. So those things are mentioned in this YouTube video links. I will give you these links. You can just go through, and it may be helpful to you also. So with this, I'm just stopping this today's session. And maybe I don't know, maybe since the number of participants are more, what you can do, you can queries or anything, no? Maybe you can send it to Madhu's
Yes.
that WhatsApp group, and we'll consolidate it, and maybe we'll have one more session, or we will see what we can do our best. So once again, thank you for all attendees, participants for spending your time. And thank you, Madhu, for Krishi Consultancy giving me an opportunity for taking this session. Thank you. Thank you so much.
Yes, yes. Yes. Thank you, GB. Very much thank you, and thank you for the all participants. We are very delighted to have this session. And if we have any doubts, also we can have a separate session. I will request the GB to come to give this clarify all doubts. And if anybody require, also we can share this video and whatever the material which is shown in the video, everything will be there. And we have a further sessions on more important topics. We have a reach in all industrial experts. So we can have a very important sessions in coming future. And over to Vasan, please have a vote of thanks.
Thank
Please.
you all for attending the seminar. We hope the session was very much helpful. We have planned to conduct the next webinar in couple of weeks. Please stay connected in the WhatsApp group for further updates. We are requested to fill the feedback form at the end of the session. We will also provide the certificate for the participants. Thank you so much. Have a good night.